Welcome to the video demonstration of an automated test of a constraint join protocol implementation with the F-Interop platform. This video is brought to you by the University of Montenegro and the SPOTS team. You can find more details about the SPOTS project at spots.ac.me. We present an overview of how constraint join protocol fits within the 6-dish protocol stack. On the very bottom, you can see the physical and MAC layers standardized within the IEEE 802.15.4 standard. IETF 6-dish builds on top of the TSCH MAC layer of IEEE 802.15.4 and defines the missing pieces for use of TSCH in IPv6 networks. Upper layers used by 6-dish include 6-LoWPAN compression mechanism of IPv6, UDP, and co-op. When a new node attempts to join a 6-dish network, it executes a constraint join protocol. Constraint join protocol messages are secured using the OSCORE mechanism that encrypts and integrity protects co-op messages. The F-Interop platforms enables remote and automated testing of diverse Internet of Things technologies, including 6-dish. As part of the SPOTS project, we are extending the 6-dish testing tool of F-Interop with the OSCORE and constraint join protocol test suites. This slide illustrates the architecture of the F-Interop platform and the 6-dish testing tool. The user, sitting in a remote location, connects to the F-Interop platform through a web-based graphical interface. The user selects a test it wants to run and downloads an F-Interop component called agent that executes locally on the user's machine. The user connects IoT devices it wants to test to its machine, and the F-Interop agent will then program a sniffer on one of the devices, and in case of a conformance test, a reference implementation of 6-dish on another device. The user's implementation under test will then communicate over radio to the reference implementation as instructed by the agent. The agent will report the sniffed packets to the 6-dish testing tool running in the cloud. The testing tool uses Wireshark to dissect packets and verify conformance as specified by individual test cases. The demo setup is slightly different from the one presented in the previous slide. We will not be using the agent component of F-Interop, and we will instead upload the sniffed trace of the test execution through the web interface. As an implementation under test, we are using the OpenWSN project that implements the latest version of the constraint join protocol. We will use OpenWSN in emulation mode and sniff the packets that are exchanged in the emulated network. A new node that attempts to join a 6-dish network is in 6-dish terminology called a pledge. The pledge sends a message called join request to a central entity called JRC. The JRC authenticates and authorizes the pledge to join by sending a message called join response. All constraint join protocol messages are encrypted and authenticated using OSCORE. The actual test we will run tests the compliance of an implementation under test according to the official 6-dish test description. You can see the technical details of this test on the right. Only if all the steps of the test pass the automated checks of F-Interop, the final verdict issued is a pass. I will now proceed to the demonstration. I will compile the latest firmware of the OpenWSN project. I will compile with the options set to the simulation mode and also enable layer 2 security features that trigger the execution of the constraint join protocol. Once the firmware is compiled and linked, I will launch the OpenWSN software in the simulation mode. I will launch the simulation mode with two nodes, one that will act as the DAG root of the network and the second one that will act as the pledge. The role of the JRC is implemented within the OpenWSN software, while the role of the pledge is implemented in firmware. The command launched the emulation of two 6-dish nodes, and the nodes are hanging until we assign the role of the DAG root to one of them. Before doing that, I will switch to the F-Interop web interface. From the drop-down menu, I will select that I want to execute a secjoin01 test. The first prompt asks for the name of the companies that are executing the test. Since this is a compliance test, I will enter University of Montenegro in both fields. The following prompt asks for the parameters of the 6-dish stack, like the addresses of the nodes participating in the network. The default values are those that are used by the OpenWSN project, so I will leave the fields unchanged and proceed. The following prompt asks for the parameters of the OS core layer, needed for decryption and authentication of the constraint join protocol messages. The default values are those specified by the official 6-dish test description and the ones implemented by the OpenWSN project, so I will leave the fields unchanged and proceed. The configuration step of the test is launched, and the prompt asks to verify the configuration of the implementation. The OpenWSN firmware was compiled with the necessary options, so I will confirm and proceed. The following step is on preconditions for the test execution. From the prompt, we can see that the DAG route and one node should be switched off and that we should switch on the sniffer and open Wireshark. I will now do this and start a packet capture in Wireshark on the TON interface, where the emulated packets will be exchanged. Since the network has still not been formed, we don't see any packets in Wireshark. We return to the F-Interop web interface and proceed to the next step. The next prompt corresponds to the step 0 of the test. It asks to switch on the DAG route and the node that acts as a pledge. To do this, we will issue a command in OpenWSN software that one node should act as the DAG route. Once we do that, we need to give it some time for the network to form and for the nodes to execute the constraint join protocol. Once we do that, we submit and proceed. The following prompt asks to stop the Wireshark packet capture and save the trace and upload it to F-Interop. In the F-Interop web interface, I will select the saved trace and upload it for processing. Now the test execution begins on F-Interop side and the packet trace is processed for compliance with the specification. We can see that all the steps passed and that the verdict issued by the F-Interop platform is a pass. This confirms that the OpenWSN implementation of the constraint join protocol is compliant with the standard specification. Thank you for following this demo. Stay tuned for future demonstrations related to the ACE framework and F-Interop.